Okay. Welcome, everybody. So by the end of class today, you guys are going to be able to tell which fractions are greater than or less than other fractions. And we're going to be using non-equivalent fractions and turning them into equivalent fractions to make it easier to tell. All right. So I'm just going to take a little bit of time and I am going to check for understanding. Do you guys, can somebody tell me what the denominator is? Amy.
It's the
Oh, Brian, go ahead. No, Brian, go ahead.
it's the bottom. It's the number on the bottom of a fraction.
Okay, and what does that number on the bottom represent, Brian?
I think I actually do not know.
That is quite all right. So the number on the bottom is, we're going back to Monday's lesson. We learned that it is the parts of a whole, right? So if I have 4/7, how many denominators do I need in order to have a whole?
You would need 7.
Excellent. So it's the parts of a whole. Amy, can you tell me what the numerator is?
The top number.
Okay. Can you tell me what the numerator means?
It's a part of a number.
Okay. So the numerator, once again, using the example of 4/7, okay. If 7 is our whole, if we need 7 parts to make one whole, and there's 4, what do you think that 4 is?
Part of that 7.
Yes, excellent, excellent, good job. I am going to screen share really quick and we are going to do this together. Okay, let me get here. All right, so what I want you guys to do right now is I want you guys to write down 4/7 and 3/5. Okay, I'll give you guys just a second to do that. Okay. So now if I was to ask you guys out of the gate, which one do you think is greater than the other one? Amy, which one do you think is greater?
The 3/5.
And why do you think that?
Because the 3 is closer to the 5 than the 4 is to 7.
Okay. Okay, that's very interesting. But how can you show us? Do you know any ways that you can show us?
Maybe with a pi.
You could use a pie graph. You could use a pie graph. We're going to be using a bar graph today. I want you guys, what I want right now is for you guys to show me 4/7 on a bar graph. If you have any trouble, let me know. So Brian, how many squares are going to be in your bar graph?
There's going to be 7 in total, but 4 would be filled out.
4 will be filled out. And which one is the 7 again?
The denominator.
And which one's the numerator, Amy?
The number on top.
The number on top, which is also?
The numerator.
Okay. So, can you guys show me your papers, please?
I am not ready yet. I am so sorry.
So, right.
Here is mine.
Okay. All right. So for this, we would actually normally be using graph paper, because what's some mistakes that we can make when drawing out our bar graphs, Amy?
Putting too many squares.
Putting too many squares. Yes, absolutely. Putting too many squares. And what's another problem we can have without using graph paper, Brian?
You could get misleaded by the numbers.
You can get misleaded by the numbers. And also too, as we've seen with everybody, the drawings aren't always exactly equally apart. And as we know, the denominator is broken up into the equal parts that make a whole. Okay, so we're just going to keep that in mind, because do you think it's a little bit difficult maybe to tell which one's bigger and which one's smaller, like which one's greater than and less than, by just drawing them out?
It would be harder, yeah.
Yeah, it would be. It would be, Brian. So but you guys did a great job. So this is 4/7, right? So we've got 7 boxes and we have 4 of them filled out. And then we've got 5 boxes with 3 of them filled out for 3/5. Okay. So what do we have to do? We want to make these boxes, because 3/5 is just a little bit longer. We want to make these boxes equal. Okay. So can you tell me what an equivalent fraction is, Amy?
Numbers that are the same,
Which numbers that are the same?
the numerators?
Oh, very close, very close. If we want equal, right? So we want the parts of the whole to be equal. Which one is the parts of the whole, the denominator or numerator?
Denominator.
Excellent, excellent. So we want, if the parts of the whole to be equal, what do we want to be equal then? The
Denominator.
Absolutely. Okay. So now you guys have already covered this week on how to change unequivalent fractions to equivalent fractions, correct?
That's good.
So just by looking at this, we have 4/7 and 3/5. So we're going to need the same denominators on the bottom, right? Brian, can you tell me how we do that?
From what I remember, actually, I forgot.
That's quite all right, Brian. That's quite all right. So what we want to do is we want to find out which number both of those denominators will go into. Which ones are our denominators, Brian?
The bottom one.
The bottom one. So go ahead and say the denominators for the problem that we have right now.
So then the denominators we have are 7 for 4 out of 7. And then for 3/5, we have 5 for that denominator.
Excellent. So can you tell me which number those will both go into equally?
That would go into 35.
Excellent job. So what do you think we're going to do now? What do you think the next step is? How many times will 7 go into 35?
I'd go in 5 times.
Okay, so what do you do with that 5?
You'd multiply it by 7 to make it 35. If I'm
And
mistaken.
what was that?
That is all I think I remember.
That's okay. That's okay. If we do something to the bottom, we also, if we do something to the denominator, we also have to do it to
Do
the
it to the
numerator.
top. Yeah.
Right. So what do you think what does 4/7 become then?
That would become 20 out of 35, if I'm not mistaken.
Excellent. Excellent. Go ahead and start drawing that on your paper. And I'm going to ask Amy, what about 3/5?
To make it a common denominator?
Yes. To make it, what else do we call it? Equivalent.
Equivalent.
Yes. So what do we do with 3/5?
We have to times the 3 by 7 and times the 5 by 7.
Okay, and what do you end up with?
21 over 35.
21 over 35. So now what is our denominator with these new problems?
35.
35, excellent job. And what's our numerators? Give me the fractions with both denominators and numerators. Let's go, Brian.
The numerator would be 21, and then the denominator would be 35 for 3 over 5.
Excellent. So what's the two fractions we have now?
So the true fractions we have now for 3 out of 5 are 21 over 35. And then for 4 over 7, we have 20 over 35.
So if we were to graph these right now, which one do you think would be closer to finishing up the bar, to filling it out?
3 over 5.
3 over 5. And how did you get that? Why do you think that?
Because we multiplied the denominators by each other. So then it ended up being 21 over 35, which is closer than 20 over 35.
What are we trying to get closer to?
The denominator, the whole number.
The whole number. Okay. Let's take a quick peek here and see what we got. So this one is our 20 over 35. Okay, and it's filled out. And now 21 over 35, you're right, there's one extra bar. And what happens if we fill up the rest of this bar? We end up getting what?
A whole number?
Excellent. Thank you, Amy. Absolutely, positively excellent. So what I'm going to have you guys do right now is I am going to have you guys pair share. You guys are going to get together. I want both of you to come up with your own unequivalent fractions. And then you guys are going to find out together on both your problems, which one is greater and which one is less than. So just to finish off really quick for this session, which one out of 4/7 and 3/5? Go ahead and give me the answer. Brian, you've been doing an amazing job. Go ahead.
3/5 would be bigger
3/5 would be bigger because
because it has the bigger number, the bigger numerator when you multiply it and you find it out.
excellent job. So we are going to go into groups. You guys are going to work on coming up with your own fractions. I want them to be unequivalent. You guys are going to change them to equivalent fractions. And you guys are going to help each other solve which one's greater, which one's less than. Okay?
Okay.
All right, guys, go ahead and break into groups.